Thank you very much, Dr. Chen, Dr. O'Krenick. And thank you, Dr. Severson. You're truly a giant, and hopefully what I talk about here will show how we've stood on your shoulders to gain some new perspective. I'll tell you a little bit about how we approached using wearable technologies for telementoring. This is through our charity, Hernia Repair for the Underserved. And the background here is just that inguinal hernias are so prevalent in the world, but the standard of care for them is so varied globally. Outside the United States, 80% of those repairs are tissue-based. And pediatric operations are largely unavailable in places like Port-au-Prince. But surgery is cost-effective, there's very little morbidity, and it just turns out to be the sort of perfect storm for the types of interventions we can do and we can bring in education. So the charity was started in 2003 by Dr. Gilbert and Dr. Philippi. We have 12 physicians and surgeons who serve on the board, and the mission in general is really just to provide free surgery for patients who can't afford it in resource-poor areas in the Western Hemisphere. But then we've carried that into an education model where we train surgeons who will then become trainers, much like what Dr. Severson spoke about. And then in doing so, we create a sustainable model and help a community build its own capacity over time. And where we've worked before are 5 countries and 16 hospitals, and they include Dominican Republic and Haiti, Ecuador, Paraguay, and Brazil, which are all just varied in terms of what their experiences are and in terms of what types of populations they have that are needy. Brazil and Sao Paulo, it's a very different situation than it would be in Port-au-Prince after the earthquake. We developed an education program, and much like what Dr. Severson said, we had an established working relationship with surgeons that operate in these areas. We would conduct in-person trainings. We would go through a 5-course training protocol, face-to-face, where a surgeon there would perform 5 Liechtenstein hernia repairs. And then after completion of training, that surgeon would become certified. They'd demonstrate their proficiency. And then from that, we would assign regional trainers who would then be the sort of center of excellence and the trainer that would train other surgeons in the area. After an interval, we'd try our best to measure their proficiency and see that our effect had a lasting effect. And then we'd encourage their participation in the global surgical educational network. So the real holy grail here is that we can carry out our regional-based protocol and have it expand out into the remote areas of a country. We've already started to do that in Brazil. We started in Sao Paulo, where we had a center where several surgeons came from remote areas of the country to train. They became regional trainers, and then they would go out into smaller communities in the state of Sao Paulo and conduct their own training series. And then in order to demonstrate that the surgeons have maintained proficiency, we could fly all the way back to Sao Paulo or to Port-au-Prince and watch them demonstrate a procedure. But we also thought that we might be able to just capture videos and have them send them to us. And this might be easily accomplished by giving them a GoPro or giving them a Google Glass. This was back in 2013, 2014, when Google Glass was still a thing. And then we rated the videos that we would get through a web portal. It's called Surgis. And we would use the operative performance rating scale that was first described by Southern Illinois University to actually get a numerical rating, but also free-form commentary about the performance of the operation. And then after the completion of the training series, we would encourage the folks that had been a part of it to join the International Hernia Collaboration, which is Brian Jacobs' brainchild, and also overseen by Dr. Chen, which now is over 3,000 members, including surgeons and industry. And then here's an example of one of the residents that was present in Haiti for one of our in-person trainings, and afterwards she became a part of this global network and posted an issue of a 3-year-old boy who had a scrotal hernia, and it's something that we're not really that used to seeing over here in our neck of the woods. But within several hours, she had 4 expert opinions from across the globe. Dr. Severson and I are going to share this very same photo because this is a shining example of how teleproctoring kind of got started in Haiti. This was our idea of it. We have a state-of-the-art facility that has a point-of-view camera installed in an overhead light and is being broadcast to monitors and then to a separate room where learners are learning. But our idea was to sort of take that into a more portable fashion. So we thought, why not use wearable tech, GoPros and Google Glass? And you kind of separate that into an asynchronous type of wearable tech and a synchronous type of wearable teleproctoring. Asynchronous we kind of think of as old school technology. Here's an RCA VHS capture camcorder where we just video record something and then have them send us the tapes. We'll review the tapes, we'll let you know how you did. And then the synchronous end of things, this is the more sort of newfangled, very sexy technology that can go bi-directional and be in real time, things like Google Glass, streaming, Microsoft HoloLens, and the things that are exciting and coming down the pike. So some features of asynchronous video capture is that you have to have a device, you have to have a way to store the data, and then your communication is essentially one way. You capture the video, you send it, and then you get an answer back at an interval. Because it's sort of lo-fi, it's lower cost, there's less infrastructure that's required of it. And really the purpose of this, we found, was to use it for demonstrations of maintenance of proficiency. So here's a screen capture of what the Surgis portal looks like and us going through the OPRS while looking at a video of a surgeon in Haiti performing an inguinal hernia repair. At the end of one of the series, we thought it might be a good idea to just leave a GoPro with the surgeons that are there and have them strap it to their heads. That way they can capture, excuse me, a video with very good quality. And so here's an example of that video, just a clip of it. And this is a resident performing a Liechtenstein repair, wearing a GoPro. You can see we've got pretty good resolution. We can see the structures pretty well. Excuse me. We can even identify the nerves. All right. And it's just to show some mesh being sewn in. And then here's a video of sort of what the MacGyvered system that we had to use was like with laparoscopic hernia repair that they performed in Haiti. Excuse me. So this is showing a monitor that's sitting on the ground and somebody is recording the image of it on an iPhone. And this is using the Surgis platform. We type in a comment that tags to a particular time in the video. It gets registered in an archive, and then this archive is shared with the surgeon, and they can review it just like a football video would be, with illustrations and also with particular ratings of exactly what steps of the operation were performed. Some features of using the GoPro, I mean, it's a primary video capture device, uses mini SD and USB for data storage. The price is somewhere in the order of $250. And you get a kind of a sense of what the price overall is to use GoPros as a telementoring platform. We used a Vimeo business account to be able to store our cloud-based videos after they would capture them. We would upload them and use them through Surgis. So in contrast, synchronous telementoring using wearable tech is real time. It's meant to be bidirectional, where we stream audio and video live. We have two-way communication as a possibility. There's a little bit of higher cost associated with it, and it sure does require a whole lot more infrastructure and resources. Our first foray into it was using Google Glass. So here's Dr. Jacob and Dr. Philippi modeling Google Glass back in 2014. And here's a video of our first try at using Google Glass, and you can see that there are a couple of issues with it. It's not really ergonomically designed for surgery. The surgeon had to angle it on his forehead in order to point it at the field, and it was so bled out by the lights of the operating room that you couldn't really even see the tissues that way. But after a couple of modifications, we were able to point it in the right direction and have the lights deliver a pretty high-fi picture in HD. And we streamed it through a free live streaming platform that's web-based. And this is what this is the image that the surgeon would see in the prism of Google Glass as he was operating. This is in Paraguay. And then from the web, you could also see a live stream of that exact point of view, and we could crowdsource opinions, which would also populate in the prism field of what the surgeon was seeing. And this is just to demonstrate within the operating room in Paraguay, a laptop showing what the stream looks like, and then me turning very slowly to show you what was happening in the operative field with the surgeon wearing Google Glass and streaming at the same time. Google Glass had some pros and some cons. It was about $2,000. We required some Wi-Fi, which in our home of Los Angeles costs somewhere around $150 a month, but which we learned in Haiti is an exorbitant amount of money to be able to support. Most people in Haiti, though, do have smartphones, even despite the destitute conditions after the earthquake. And then we did have to have a streaming platform which would support that type of infrastructure. I think the next steps of what we're seeing now are augmented reality, which is where we have an overlay of an image that is also in real time. It can provide a two-way communication and even telestration. So this is Dr. Zotek demonstrating one type of augmented reality glass. And here's an example of him performing a hernia repair with Dr. Tofi in a remote location, seeing exactly what he sees, and then actually illustrating things for him to perform while he's operating. And this image is overlaid on the field that he is operating in. And he did this with the support of AMA Inc. And this is Dr. Zotek giving a talk demonstrating wearing these augmented reality glasses and showing that in 3 dimensions he is gesturing and able to select things that he would like to see in his field while he's performing. He may select a CT scan, he may, excuse me, select a Facebook feed from IHC. And several different types of augmented reality glasses are now becoming available, and although they are more expensive than Google Glass and GoPros, I think they are coming down the pike. So with our experience, we've kind of devised a wish list of what we might expect to see with the near future of teleproctoring. In terms of hardware, we'd like something that's wearable with good point-of-view audio-video capture, something capable of high-speed internet, high bandwidth, and high Wi-Fi in a remote area, a good data storage system, a battery backup, and a heat sink so that the device doesn't burn the surgeon's head while he's operating. And then in terms of software, what we would hope for is good video and 3D image compression and streaming, two-way communication, good DVR-style playback with zoom and editing features for telestration, virtual anatomy instruments and prosthetics that can be engineered directly for this two-way type of communication, software that's gesture navigable and easy to share via social media interface and across multiple platforms. But most importantly, with that very sophisticated technology, to be able to scale it down into something that is usable in a very resource-poor setting. With that, thank you very much.